Pomodoro Joe for Friday, January 20th, 2023. Today we're looking at LeetCode problem 491, non-decreasing subsequences. This is a medium problem, and the problem statement says, given an integer array nums, return all the different possible non-decreasing subsequences of the given array with at least 2 elements. You may return the answer in any order. So we'll set 25 minutes on a Pomodoro timer and get started. I'm going to try this recursively. It's probably going to backfire, but it's worth a shot. Okay, so the first thing to note is with our recursive algorithm, we need some base case. And that's going to be checking if we have fewer than 2 elements in our nums. So if the length of our nums is less than 2, then we only have 1 or no elements, and we can just return. We'll have to wrap it in an array, but we can just return our nums. So that's the straightforward part. Now, this does present a problem though, because right here it says we need at least 2 elements. So we can't return something that has 1 element in it as part of our recursive algorithm. Okay, so this leads us to an internal function. We'll create an internal algorithm that will go through, create all of the subsequences, then we'll go back through all of those and remove the ones that don't have at least 2 elements. Not great, but it simplifies our recursion a bit. And we will call this okay. So that helps there. Now we'll still need some result. Make it an empty list to begin with, and then we will return our result. How do we handle the rest of our recursive cases? So we will grab the first element off of our list. So the first num is going to be nums at 0. Then from there, we'll say, give us all the remaining possible subsequences that you can make with the rest of the numbers. So let's call this subsequences. And we'll call find subsequences recurse, because this is our recursive call. And we'll be reducing our problem set by 1 by just calling this on the rest of the numbers. All right, then for every subsequence in our subsequences, if we can add this num back to the front, so if the num is less than or equal to our subsequence at index 0, then we can add this to our result. So we basically create a new subsequence by adding our num to this subsequence. We better check here if subsequence has at least 1 element though. So if our subsequence length is less than 1, well then we'll just continue. And finally, even if we can't add this number to the beginning of our subsequence, that subsequence is still valid. So we'll add the subsequence to our result. Now there's one more thing I think I missed. This takes care of all the times that our number can be added to the front of a subsequence. It doesn't take care of all the times when our number is the last number in the subsequence. So we can also append our number as a potential ending point in the subsequence. Okay, so this handles the recursive situation. We'll basically say if we have fewer than 2 elements, we'll just return the nums. Otherwise, we grab the number off the front. We can possibly treat that as one subsequence. Then we find all the remaining subsequences, go through, see if we can add the number back on the front, and if we can, then it becomes an option. If we can't, then that subsequence by itself is an option. All right, and then we return the result. So in our outside function, we'll get all of the subsequences, and that will be equal to our recursive call here. Passing in our nums. And now we have to filter these to meet our criteria. So I will have a valid subsequence. And this will be a set. So a set will help us remove any duplicates, which is also one of the requirements. So for every subsequence in all the subsequences, if the length of that subsequence if it's less than 2, then we'll just continue, because this isn't a valid subsequence for our purpose. Otherwise, we will add it, no, not to that, into our valid subsequences. And at the very end, we will return our valid subsequences. Couple things that aren't quite right yet. So our return value. Up here it says it's a list of lists of integers. Right here, this is a set, so we'll need to convert this into a list. That's pretty easy to do. The other problem here is we're trying to add a list into a set. Unfortunately, you can't do that in Python. In Python, a list is not a hashable object, so we will have to convert this into a tuple as well before we can put it into our set. And that should work. Let's give it a shot. Of course it doesn't. This should just be subsequence singular. Now let's try that. All right, so that does work. It's not great, but it works. And of course, being recursive, it's going to be blazing fast, right? Let's submit this and see how well we do. Oh, that actually passes. I am quite shocked at that. I am terribly shocked. Okay, I'm shocked that that passes. We actually do really well. We beat 82% of other submissions in terms of runtime, and we beat about 20% in terms of memory. What? How is that possible? I am totally shocked by this. All right, so we still have a couple minutes left on the Pomodoro, so I'm going to try to go through another way to handle this a little bit differently. I'm not going to be able to explain it as well, but let's start with this. We have some index, and that's going to be equal to the length of our nums minus 1. So we'll be starting from the back now, and we'll work our way forward. So while that index is less than, or sorry, greater than or equal to 0, make sure that we decrement our index, otherwise we'll have an infinite loop. And down at the end here, we will return some result. Okay, the other things we are going to need, we'll have some result. And in fact, we'll make this a set. And we'll need a working result. Or we'll call this a working set. That's also a set. All right. So we'll grab a number. So the current number will be the nums at our index. And what can we do with it? Well, for every, let's just call it a sub for, I'm running out of time. So for every subsequence in our result set. So for every subsequence that's in our result set, if this num is less than or equal to that subsequences element 0, then we can add this num to the front of that subsequence. And so then we can have our working set. We'll add, and again, we'll have to make this a tuple, but it will be our, let's see, our num plus this sub and wrapped in a tuple. That gets added to our working set. So let's see, we'll need to create or clear our working set each time. So let's just create the working set inside our loop. All right, so we'll create a working set inside the loop. So if this makes a valid subarray, we'll add it to our working set and keep going. Otherwise, we don't add it. Great. And similarly with the other algorithm, we'll want to add our number as a potential ending to our working set to begin with. So we'll add tuple of our number itself to our working set. All right, and then outside of the for loop, once we've built up all of our potential results with this working set, we will essentially say the result is the union of our result and the working set. And then similarly to how we did it before, we still need to go for every sub in our result. I should probably have done this, maybe not called this result. I'll call this like, shoot, I am out of time. Well, it's similar where we have to remove all of the elements that are not at least 2 elements long. We have to remove all the subarrays that don't contain at least 2 elements. So we'll have like final result. We'll just go ahead and make that an array to start with. That'll make things easier. For every sub in our result, if the length of that sub is less than 2, we'll just continue. Otherwise, we can say on the final result, we'll append that sub, and then we can return the final result. Whew, okay. I didn't explain that one very well. It's a little bit shorter, but hopefully this will work. And of course, I have errors. For every sub in the result. The sub should have at least one number. I'm guessing somehow I'm not. Like, this is probably unwrapping in a bad way. Let's do that. Let's say working set is a set, and in the working set, we'll just add, whoops, this tuple of num. See if that helps. All right, so this one needs to be converted back into a list before we can add them together. It's a little bit of conversion madness with this one, converting back and forth between list and tuples. It seems to work. Let's submit that and see how our runtime is. Ooh, boy, howdy, that's a good one. This one beats 93.2% of other algorithms for runtime, and it beats 95.71% for memory. This is a winner of an algorithm, folks. So take a look at this one. I haven't seen other people do it this way, so I don't know if this is a normal pattern that people follow. This is just what I came up with. Hopefully you enjoyed it. Hopefully you learned something. Hopefully you had some fun. And please remember to write better code.